welcome to this preview video for an electronic Simon app using MIT App Inventor. For those of you who don't know, Electronic Simon was a handheld game manufactured and distributed by Milton Bradley, and it was basically you playing Simon Says against a little computerized device. The buttons would light up, each button had a specific sound that it would make, and you had to repeat the pattern as it was given to you. Every time you repeated the pattern successfully, it would increment and become a little bit longer, and you'd have a little bit less time to get the pattern repeated, and if you entered it wrong, it was game over. Herein is an approach to simulating Simon using MIT's App Inventor. I've got the emulator up and running already over here, and right here you can see the user interface. I can't click the buttons just yet, but I can select a level to start at, and I just set it as levels 1 through 20, but default is starting off at level 3. It's a pretty easy pattern to repeat. You click button start, and the app generates a random pattern for you to press, in this case green, green, red. And it'll play the next pattern that's going to have 4 values in it. Green, green, red, yellow. It lets me know that it's my turn. And it's giving me a little bit of feedback. Oh, game over, got it wrong. Now let's try it where we start off with a little bit longer code to work with. So here's it starting off at level 5. Here's the pattern. Advances to level 6. It's telling us to pay attention. And we're getting that positive feedback as we get things right. But if we make that mistake, it goes to game over. So along with this app, there is a tutorial document that will guide you through some of the content, concepts and objectives you're going to be working with for this app. The app is going to have you use randomness and create a simulation of a real-world model, being the electronic Simon game itself. You're going to have to define global variables, lists, and assign them their initial values. You're going to have to navigate through those lists using indexing. And a lot of the lists that we have are going to be navigated in parallel to keep things organized and to allow for a little bit higher level of abstraction as you're working. You're also going to see a lot of examples of procedures with parameters used to help keep the code concise. We're going to use a random number block to generate a range of numbers. I think each one gets assigned, like green is a 1, red is a 2, yellow is a 3, and blue is a 4. And then there's going to be an if-else conditions along with a iterative for loop to determine whether or not what you've entered in is the same as the list that was generated. So let's walk through the code real quick. And basically on here, the main part of the code is we start off with 4 parallel lists. The first 2 lists are the color list and the darkened list, so that we can alternate between the button being lit up and the button being turned off. The next list we have is a list of the actual buttons itself, so we can use a lot of for any button blocks to set them enabled, set them disabled, set the background color, things like that. And then just while we're at that, while we're indexing all the buttons, we're just going to keep the sounds associated with each button there. The real clever part of this app deals with the 2 clock timers. There's a clock on timer and there's a clock off timer. The clock on timer has a 1000 millisecond interval, and the clock off timer has a 500 millisecond interval. And what happens in the blocks is when the user presses the start button, a list is generated. If the generated list is empty, it'll go all the way up to the level that was selected by the slider, adding a random 1 to 4 number. Once that happens, after that, the on-time timer is enabled, so you're told to pay attention, and the on-time timer is going to sequence through creating the lights and sound and turning on the off timer, which is going to darken the buttons half a second later. So the net effect is the button is illuminated for half a second and then everything's dark, and then the next button is played, and it goes through that, incrementing the count basically until the count is greater than the length of the generated list. At that point, we know that the whole list has been displayed, and we're waiting for the user to press the green, red, yellow, or blue button. Each one of these calls the same button pressed procedure with a different parameter, and it adds that parameter to the players list and calls for a correct check. And the correct check is a for each number loop with two if statements nested inside. The first one is just checking outright if the player list is equal to the generated list. If it is, turn the buttons off, start the next round procedure, break out of this loop because we're done. If not, it checks each individual generated list item and player list item to see that they're the same. If they are the same, you get a little encouragement. If not, it's game over, and then the game resets. All this code will be linked out in the video description along with this tutorial document. I hope you enjoy working your way through this tutorial. I had a lot of fun making it.